CS8461 Operating Systems Laboratory. Exercise number 9. Implementation of deadlock detection algorithm. See the picture. Here the process 1 is waiting for resource 2. At the same time, the resource 1 is assigned to process 1. Likewise, it has happened in the process 2 also. So, there is a circular formation found. So, here deadlock is detected. Let's see the execution. Before doing the execution, we want to know the concept of this program. Okay, that is a deadlock. That is, what is deadlock? Deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. So this is an example for deadlock detection. Then the characteristics of deadlock. There is a 4 characteristics. First one, mutual exclusion. What is mutual exclusion? There should be a resource that can only be held by one process at a time. See the picture, the process is allocated one resource at a time. That is a mutual exclusion. The next one, hold and wait. A process can hold multiple resources and still request more resources from other process, okay, which are holding them. See the picture, the process 2 is allocated resource 2 and resource 3, but it is giving the request to resource 1. Okay, this is a hold and wait. Then third one, non-preemption. A resource cannot be preempted from a process by force. Forcefully we can't do anything in this method of non-preemption. A process can only release a resource voluntarily. If the process voluntarily release the resource, then the next process can take it. Okay. And last one, that is a circular wait. A process is waiting for the resource held by second process. Okay. Like this way, the circular formation is formed, means that is a circular wait. This method we are going to implement in this deadlock detection. Resource allocation graph and wait for graph. See the first picture, that is a resource allocation graph. This will give the overall information about all the process and all the resources. Okay, how many processes are there and which process is connected to which resource, and everything will be given in this resource allocation graph. Next one is wait for graph. We are minimizing this resource allocation graph into small, minimizing that. Here in this wait for graph, only the process will be present. Okay. So the main task of the operating system is detecting the deadlock. The OS can detect the deadlock with the help of resource allocation graph. Let's see the program. So aim of this program, to write a C program to implement deadlock detection algorithm. These are the algorithms. Here starting the program, and we are allocating, mentioning the matrices, that allocation matrix, request matrix, available vector, everything will be initialized and the formulas will be defined. Okay, let's see the program. Header file is included and the declaration is finished, and inside the main function we are allocating, we are initializing that allocation graph, request graph available in the two matrix. Okay, 2-dimensional matrix we are including, and we want to take the input as a number of process and number of resources. This is initialized, and here the request matrix, for that we use a for loop, and for allocation matrix and resource calculation will be there. Okay, here marking the process with 0 allocation. For that we have written this routine, and this is a program, and checking for unmarked processes, then the deadlock will be detected. So this is the output. we are entering the number of process and resources. From that, we are taking the request matrix and allocation matrix. Likewise, we are using that calculation method and the deadlock is detected. Let's see the execution. For executing this program, we are using Ubuntu OS. Okay, this is a program. Then open the terminal. LS for listing the programs, and for compiling gcc-o, that executable file, and the file name EX.NO.9. Okay, this is for compilation. There is no error. Then for execution, /output. So first enter number of process 4 and enter number of resources 5. We are entering the resources. Enter the request matrix 01001 and 00101 00001 10101. This is the request matrix. Then next one, enter the allocation matrix. That is 10110 11000 00010. The next one 0000. So here deadlock is detected. So we have successfully executed the deadlock detected program.